So happy Monday. This is the lecture about mixed practice. So we're just going to do some word problems. We're going to use percentage. We're going to use proportion. We're going to do mixtures and all these applications we did with fractions. So let's start. We're just going to start and just go over some of these. Let's start with number 24. Number 24, we have there are 425 students, statistics students at Northwest Vista, of which 35% plan to attend nursing school. If all of the students who plan to attend nursing school are enrolled in statistics this semester, what percent they give the number of students body plans to attend nursing school? So any ideas how to do that? Any ideas? So we have 35%. We know how many are statistics. Any ideas how to do that?
What was the question again?
Okay, so we're doing number 24. So there are 425 statistics students, right? And that's 35%, no, of which, so 35% of this number plan to attend nursing school, okay? If all of the students who plan to attend nursing school are enrolled in statistics, what percent of the Northwest Vista student body plans to attend nursing school?
Would it be 35% over 15,000?
35% over?
I could be wrong. 15,435.
Okay, so let's first find, so this is the Northwest Vista body, student body, right? So in Northwest Vista, we have 15,000 people, right? 15,000 students. Okay. We have also 425 statistics students, right?
Yes.
Don't you have to subtract 15,435 by the 425 statistics students? I think.
So we have statistics students and we have nursing who are going to nursing school. So can we find out how many go to nursing, how many are going to go to nursing school? How many students? So if you take 35% of 425, that's going to give me how many are going to nursing school, right?
Mm-hmm.
So when I do 425 times 0.35, it's going to give me how many go to nursing school, are going to plan to go to nursing school. Yes? We have 425 multiplied by 0.35. That's going to be 148.7. I'm going to say 148 students. Okay. So 148 students are going to go to nursing school. Yes?
Yes.
If all the students who plan attending nursing school are enrolled, so that means there are no more students who don't take statistics, what percent are going to go to nursing school? So they're asking, what percent is 148 of 15,000?
Okay.
So what percent? How are you going to find the percent? The nursing out of the total, right?
Mm-hmm.
Yeah, so we're going to divide 148 divided by 15,000.
435.
Yes. And that's gonna be the decimal form of the percent.
Mhm.
148 when I divide by 15,435 is gonna be 0.0095886. That's what I have in my calculator. So how many percent? When I move the decimal 2 places, it's going to be here, right?
Mhm.
And let's round 2 decimal places. So it's going to be how many percent? 0.90 what?
96.
86%. Okay, so that's my answer. 0.96% of the Northwest Vista students, which is less than 1%, or yeah, a little less than 1%, are students who are gonna go, who are planning to attend nursing school. Make sense?
Yes, ma'am.
So this is like a 2-step question. First, you have to find how many students are gonna go to a nursing school, and then what percent of the student body is that? Make sense? Okay. So that was number 24. Let's go ahead and do number 25. So number 25, we have a pre-election survey show that 5 out of every 13 registered voters would vote in an election. On this rate, how many people will be expected to vote in a town of 5,850 registered votes? So how are you going to set up this? The question is, how many people are expected to vote? So how many people will be expected to vote? So we can set up a proportion, or we can do the percentage, the same way I explained the question in the homework. So if you want, you can just do proportion. Probably it's easier. How many 13 out of, so we have, let's set up the proportion. We have how many 5 out of every 13 will vote. So 5 will vote. So I have in the top how many will vote over the register. How many are registered?
Okay, so would it be 5/13 equals X over 5,850?
Absolutely. Good job. Good job. 5,850. That's right. Good job. And then from here, if I want to get X by itself, what I need to do? I'm multiplying 5 times, I'm multiplying the 2 numbers opposite to each other,
Mhm.
and I divide by 13, right?
Mhm.
Okay, good job. So that's what you're going to get. You're going to get X equals. So when I multiply 5 times 5850 and then divide by 13, it's going to be 2,250 people, right?
Yes, ma'am.
Okay, everybody understand that? Yes, you can, yes, Dion, that's correct. You can cross multiply. And then when you cross multiply, you have the same. 5 times 5,000 equals 13x. And then you have to divide by 13 to get X by itself. Yes, that's right. Okay, so that was number 25. Any questions? Okay, going to the next one, number 26. We have to estimate the number of trout in Big Bear Lake. A sample of 48 trout captured and tagged. After releasing them, a net captured 300 trout, of which 9 are tagged. Estimate the number of trout in Big Bear Lake. So here we have to set up a proportion again. You can set up a proportion. So how many capture, how many attacks, right? That's what you need to set up the proportion. And in this case, that, I mean, in all the cases, it doesn't matter which one is up, which one is down, but make sure you're consistent with the units, okay? So, so you can set up like how many attack, how many capture, right? So, I'm gonna put how many attacked over how many are captured, or the total, right? So how many attacked in the second one? They captured 300, 9 attacked, right? So it's gonna be 9 out of 300 equals the first time, how many are captured and tagged? See, this is captured and tagged. So it's gonna be 48 attacked the first time over the total number of all the trout in the lake, right? That's the question, over what it is, over X, right?
Yes.
Everybody understand that? So that's my proportion. So 48 attacked out of the whole population of trout in that lake. And the ratio is the same if you capture 300 and 9 of them attacked, okay? So what you're doing here, we're gonna solve for X. How you solve for X? You're gonna do the same. You're gonna cross multiply, so multiplying those two numbers, and you're gonna divide by the number across of X. 9, divide by 9. And somebody give me the answer already. You have 1 time, yes, that's correct.
Mhm.
So I'm gonna put X equals. So when I multiply 300 times 48, and then the divide by 9 is gonna be 1,600, right?
Yes, ma'am.
Thank you. So that's the question, that's the answer. Okay, everybody doing okay so far? So we're gonna go to number 27 and 28. I'm just gonna do some of those. Actually, that's the last, okay, that's only one page. Oh, come on now. I lost it. Okay, there it is. Okay, I just press here and it disappeared. Okay, 27. 27 is Kelly takes her friends out to lunch and pays for the bill. Her friends insist on paying the tip. If the bill was 38.75, if they want to leave 15% tip, how much money they need to leave for the tip? So how are they going to do that?
Would you do 38.75 times 0.15 for that 15%?
Yes, when you multiply by 1.15, that's going to give you the tip. Okay, that's correct. But here they're not asking only how much is the tip.
Mhm.
They're asking bill plus tip. That's what you need to, that's what they're gonna leave.
Okay.
How much money they need to leave. So bill plus tip. So if it's bill plus tip, that means you're gonna add it to the original bill, right?
Yep.
So which means you're gonna multiply, you're gonna add 38.75, the original bill, plus 38.75 multiplied by 0.15. So you can do that, but instead of doing all this adding and multiplying, you can technically actually multiply 38.75. It's a kind of shortcut, multiplied by 1.15, because 1.15 means the original plus the tip or plus the percent. So when I multiply, you get the same, but this is kind of less pressing on the calculator. 38.75 multiplied by 1.15 is going to be $44.56 when you round it. Okay, make sense?
Yes, ma'am.
Okay, so remember when you have to find the total, this is like a total bill, like bill plus tip, you can multiply by 1 point and then the percent, okay? And that's faster way to do that. Okay, the next one we have is number 28. If the Spurs finish the season with a record of 55 wins and 27 losses, what percent of their games, see the total games, will they have won? And you have to round to the nearest 0.1%. So they win 55, right? If I want to find the percent, I need to calculate the wins divided by the total games, always. So how many wins they have? 55. What is the total number of games? It's 55 plus 27. I'm going to just write it like this so you can have to understand why you divide it by the total, the number. So when I add those, it's going to be 82, right? So everybody can see how I get 82? I add 55 plus 27, okay? So when I divide 55 by 82, I get 0.67073171. That's what I have in my calculator. Now we have to move the decimal 2 places to get the percentage, right?
Mhm.
So it's going to be 67 point. Now 0.1 of percent is one number after the decimal. So that means I'm going to get 67.1%.
Mhm.
Okay? And this is my answer. So Spurs won 67.1% of their games. Okay, everybody good?
Yes, ma'am.
Okay, and then we have one more in this page, which is if the Spurs begin the season with record of 7 wins and 4 losses, predict how many games they will win through the 82 games of the season. So here is the question somebody was asking in the beginning on your homework. So here we have to solve this in 2 different ways, okay? So one of them is the percentage. The way we just did, we calculate the percentage of the wins, right? And then you take that percent out of 82 games. And another one is we have to set up a proportion. So I'm going to do the percentage here, and then after that I'm going to do the proportions. The way we did 28 is we find the percent. So that finding the percent is going to help us in number 29. So what is the percent? So if they have 7 wins, so they begin the season of 7 wins and 4 losses. So it's going to be 7 plus 4 is going to be out of 11. That's how you get the percent. So far the winning is 7 out of 11, which is 63.6%. And I just round it, okay? 63.3 points, I'm sorry, 63.6%, not 3. 0.6% because it's 63, 63, 63 and repeating, okay? That's the decimal I get. So they're winning with 63.6%, right? Now the question is how many games they will win if they play 82 games. So what I need to do is I need to multiply 82 times 63.6%, which is 0.636. So when I multiply that, I'm gonna get 52 games. And you round to the whole number because you're talking about games, right? And usually they're playing the whole game, obviously, right? They're not playing 0.1 game. Okay, so that's how you solve the first part of it. That's how you solve it with percent. Now let's do the same question with proportion. So here we're gonna set up the proportion. So they have 7 wins out of 11 games. And they're asking how many wins they're gonna have out of 82 games. So again, you have wins over the total. And you have to be consistent with that. And in order to solve that, I have to multiply the two numbers and divide by 11 because 11 is across X. So when I do that, when I solve that, I'm gonna get, so X is gonna be 7 times 82 divided by 11. And that's, what is that? 7 times 82 divided by 11, it's 52 games again. And of course, you round to the whole number. It's not exactly 52, it's 52.18 and so on, but you round that to the whole number, okay? So that's how you do number 29, and we already did, I think it was 34 in your homework, okay? So that's what you have for all the applications with proportions and percentages, okay? So here we're going to continue with page 25, which is going to prepare us for scientific notation and conversions. Okay, so we're going to first talk about what is exponent. So exponential expression looks like this: number with exponent n. A is the base, n is the exponent, also called power. What that means? A to the n means you're multiplying A times A times A times A n times. Okay, that's what that means. Okay, so what you're gonna do here, we're gonna have, for example, if you have 10 cubed, 10 with exponent 3, that means you're multiplying the base is 10, so multiplying 10, 10, 10, 3 times by itself, and that's gonna give me 1,000. Now, when you multiply by 10, it's really easy because the exponent tells you how many zeros you're gonna have, okay? So 10 cubed has 3 zeros, 1 or 3 zeros. 10 to the 5th is gonna have one with 5 zeros, okay? So keep that in mind. Okay, so if you have positive integer exponent, tell us how many times you multiply the base. Okay, so here we have some examples to go over. Everybody understand this so far?
Yes.
Yes. Okay. So let's go ahead and do some examples here. So if I have 10 to the first power, obviously it's just going to be 10. 10 to the fourth power is going to be 1 with 4 zeros. Okay. And how we get this? We just multiplying. Let me make this better. Multiplying 10, 10, 10 4 times. I'm just going to write it to show you how we get that. But multiplying by 10 is really easy. Just an exponent give you how many zeros. 10 squared is 10 times 10 is 100. 1 with 2 zeros, right? 10 with to the 7th power is multiplying 10, 10, 10, 7 times by itself. So it's going to be 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that's 10 millions, right? Everybody understand that?
Yes.
Okay, number 5 says, discuss what happened when you raise 10 to a positive integer power. So what happened?
It increased.
Increase the zeros?
Yeah.
Yes, that's right. That's right. Okay. So let's do number 6. We have to do it backwards now. So we have to write the number as a power of 10. So 10,000 is going to be 10. What is the power to get 10,000? How many zeros?
4.
So it's going to be 10 to the power 4. That's right. Good job. Okay. The next one is 100 million. So what is that? 10 with what power? 8. Somebody say 8. That's right. 10 to the power 8. Okay. So that's how you do those. The next one you have about negative integers. So if you have negative exponent, tell us how many times you divide by the base 10. Okay. So why you divide? Because negative exponent means reciprocal. And reciprocal of multiplication is division. Opposite of multiplication is division, right? So that's why if I have, for example, 10 to the negative third, you have 1 divided by 10, 10, 10 divided 3 times. Divide by 10 3 times. And when you write it as a fraction, it looks like 110, 110, 110, or it's going to be 0.001. So now let's do some of the examples here, and let's try to find the pattern. I'm not going to tell you right now for this one for negative. You're going to tell me number 12, where you have to discuss what happened when you raise 10 to the negative integer power. So I'm going to do the examples and think about what is the answer for this question, okay? So let's start with 10 to the negative 1. So 10 to the negative 1 is what? 1 over 10, right? And 1 over 10 is 0.1. Okay, let's do the next one. 10 to the negative 2. 10 to the negative 2 is 1 over 10 times 1 over 10, or technically multiplying 1 by 10 and 10. And it's going to be 1 over 100, which is 0.01. Then the next one is 10 to the negative 4 is going to be 1 over 10 4 times. And that will be 1 over with 4 zeros, right? So that's going to be 0.0001. okay? That's 0.1 10,000, right? And then 10 to the negative 7 is going to be 1 over 7, 1 over 10 7 times. So it's going to be 1 over 7 zeros here. Ten millions. So it's going to be point. How many zeros I need to put? There you go. Okay, you got it?
Yes, ma'am.
Okay, so from here, can you tell me what is the rule? What's happened when you raise 10 to the negative integer power? What you get? So if I have a, or I'm sorry, not a 10,
Decrease it.
yes,
You decrease it
I decrease it how many times?
by by the number of times. It says
Yes, you decrease it by the number of times with one. How many? One, right? Morgan say you get a decimal. That's correct. You get a decimal, so it's going to be 0 point. And then how many zeros I have to have here? How many zeros?
9.
N minus 1. One number less, okay? You got it? So if I have 10 to the fifth, to the negative, I'm sorry, 10 to the negative fifth. This should be negative. 10 to the negative exponent is going to be decimal, is going to be point, and then 0, 0, 0, 0. And then how many zeros is going to be one exponent smaller than the original, one number less than the original exponent. Make sense? So let's look at number 13. So number 13 is decimal, so it's point something, so it's going to be 10 to the negative. What is going to be the exponent here? We need to count the zeros. How many zeros are?
5 zeros.
After the decimal?
After the decimal, 4 zeros.
4 zeros. So what's going to be the exponent?
Negative 4.
Is it negative 4? Do you want to say it right? What is it? If this is n minus 1,
Mhm.
then it should be negative 5, Patricia said. That's right. So it's going to be negative 5. It's going to be one number bigger. Okay? Because if the exponent is negative 5, you're going to have 4 zeros. So after the decimal, there are 4 zeros, right? And the exponent is negative 5.
Gotcha.
Okay, got it? Any questions so far? So let's do that one more time. So let's count the zeros here for number 14 after the decimal. How many zeros we have? 8. That's right. The 8 zeros. So how are we going to write the exponent? 10 to the, good job, 10 to the negative 9. Okay? Any questions so far? No? Everybody good? Okay. Then you're going to go to 26, page 26. In math, order of operation exponent come before multiplying or division, right? So if I have to do 5 times 10 cubed, that means you have to do the exponent 3 first, cube first, before multiplying by 5. Yes? Everybody know that? Also, keep in mind that multiplication is not always with the X symbol. Sometimes you're using the dot, like this, or like this, with parentheses. So 5 times 10 cubed, you can write it like this or like this. Okay, so these are 3 different ways of writing 10 number times 10 with exponent. Okay. And sometimes it says it looks more tempting to start multiplying 5 times 10, but you have to do the exponent first. Keep that in mind. Okay, so always do the exponent first. That's what you're doing first. You multiply 3 times 10, and then you multiply by the number. Keep that in mind, okay? And then if I need to follow that correct order of operations, and I have to simplify this, I have to simplify this expression. So let's start with number 15. So for number 15, I have to do the exponent first, right? So technically I have to do 7 times, what is 10 squared? 1 with 2 zeros, right? And then when I multiply 7 times 100, what I'm gonna get? 700. Okay, so let me just give you a little heads up here. What all these examples we have here, they're like scientific notation. So if you have number times 10 with exponent, that's a scientific notation. So this is how we're gonna write the big numbers or small numbers, okay? But let's just focus in the order of operations right now. So let's do 16. So I have 3 times 10 to the negative 4. We're gonna do that first. So I'm gonna keep 3 times, and then 10 to the negative 4 is gonna be 0. How many zeros?
3.
3 zeros. Good job. And 1. And then when I multiply 3 times this, everything is gonna stay the same. Just 1 is gonna multiply by 3 because 0 times number is 0. So I'm gonna get 0.3 zeros, and then 1 times 3 is 3. Okay, let's do number 17 the same way. We're gonna keep the 7.45, and I'm gonna multiply by 1 with 6 zeros, right? 1, 2, 3, 4, 5, 6. Okay, now what's happened if I multiply decimal by 1 with zeros? I move the decimal how many places? 6 places, right? Because these are 6 zeros. So I'm gonna have 7, 4, 5. So you have 2 places here, and you're gonna fill out the rest with zeros. So you have 1, 2 so far, 3, 4, 5, 6. Okay, so that's gonna be 7,450,000. Everybody understanding that? See, if you notice, when you multiply by 10 or divide by 10, you don't need technical calculator because it's just moving the decimal left to right, okay? See, let me just go back here to number 16 to show you something. See, when I multiply by 10 or divide by 10, I'm moving the decimals. You have 7 points, right? When I move the decimal with 2 zeros, I'm moving it 2 places to the right. Now, when I multiply by points, like when I multiply by negative, I move the decimal to the left. So when I multiply by positive exponent, I move the decimal to the right. When I multiply 3 times 10 to the negative exponent, I move the decimal to the left. How many places? 4, right? 1, 2, 3, 4 places. Everybody see that?
Yes.
Okay, so that's the trick with multiplying and multiplying by tens. You move the decimal. Okay, so the next one, let's rewrite it and then we can just use that rule I show you when you move the decimal. See, if I use the rule for decimal, I'm gonna start with 3 and I move it to the left 6 places. Okay, or technically I need to multiply 3.14 multiply by 0.50 and 1. And when I do that, I'm gonna move this decimal 6 places. So it's gonna be 1, 2, 3, 4, 5, 6. So it's gonna be 1, 2, 3, 4, 5 zeros. 0.5 zeros. And then 314. Okay, so that's my answer. Everybody understanding this?
Yes.
So when you multiply or divide by tens, it's really easy. Okay, let's have another example. Here we have 10 times 3 squared. So what you're gonna do first, you're gonna do the square for the exponent. So that will be 10 times 3 squared is 9. 3 times 3 is 9. And when I multiply 10 times 9 is 9. This is just a trick question to see if you remember to do the exponents first. Okay, then you have another one. We have to do the exponent first. So here we have to multiply 3 times, I need to do 2.54 multiplying by itself. So 2.54 times 2.54 is gonna be 6.4516. That's right, I got the same, good job, thank you. And then when I multiply by 3, it's gonna be 19.3548. Okay, so here we needed calculator to multiply 2.54 and 2.54. Okay, now let's go ahead and do number 21. So here we have to do 7. We have to do the exponent first. Remember, don't multiply 7 times 12. So I'm multiplying 7 times, I need to see what is 12 cubed, which means 12 times 12 times 12, 3 times. Okay, somebody's giving me the answer. Thank you. 1,728, that's right. And then 1,728, I'm gonna multiply by 7, and it's gonna give me 12,096. Okay? And then the next one is a little fraction. So when you have fraction cube, we have to be careful. You have to do the fractions cube first, which means I multiply 1 times 4 times 1 over 4 times 1 over 4. Okay, that's what I'm doing first. And then I'm gonna multiply 40 by the answer. So when I multiply 1, 1, 1, when you multiply fractions, you multiply the tops is 1. And 4 times 4 is 16. When I multiply it by 4 one more time, it's gonna be 64. And then you have to reduce. So this is 40 over 1. You can reduce these two fractions. You can divide by 4 up and down. So when I divide by 4, it's gonna be 10. When I divide by 4, it's gonna be 16. And I can divide by 2 one more time. So it's gonna be 5 and 8. So make sure you reduce whatever fraction you get, reduce it. And that's what you have. Any questions on number 22? No? Okay. Then we have number 23. We have to find the mistake and we have to correct it. So where is the mistake? Can you see a mistake here? We have 3 times 4 squared. That's the original problem. Then they get 12 squared.
They multiply the 3 and the 4 instead of doing the exponent first.
Good job. That's right. And also I have in the chat that they didn't do the exponent first. So this is the operation you have to do first. Okay, so that's wrong. This is wrong step. Now, how are you going to correct it? So let's correct that. How are you going to do it right? If I want to do it and I want to get the right answer, I'm going to do 4 squared first, right? So it's going to be 3 times 4 squared is 16. 4 times 4 is 16. And then I'm going to multiply. 3 times 16 is, what is that?
48.
48, that's right. So the right answer is 48, not 144. Okay, everybody see what the difference is going to make if you don't follow the order of operations. Okay, so that was number 23. Let's continue with reducing and multiplying. So when you have when you multiply fractions, it's better to reduce first and then multiply. Okay, so that's something you have to keep in mind always. Reduce first up and down, and then multiply, not like I did here in number 22. See, number 22, I multiply first and then I reduce. It's going to be easier and faster if you reduce first and then multiply. So this is how you do it. So if I want to multiply 8 over 1 multiplied by 5 over 8, it's better if you reduce 8 and 8 up and down. Going to divide by 8, and that's going to be 5 over 1, which is just 5. Make sense? Okay, the next one is the same way. You just reduce 4.5, 4.5 is going to give me a 7. So it's easier to reduce first because if I multiply, it's going to get a big number and then I have to divide it again. So it's easier that way. Now, the next one, the same way. We have 10 and 5. The easy way is just divide by 5. It's going to be 1 down and 2 up. And then multiply what is left. So what is left? 2 times 3 in the top is going to be 6. So make sure if you have a number left in the top, you leave it in the top. If you have number left in the bottom, you leave it in the bottom. Like in this case, you have 1 times 1 is 1. 6 over 1 is just 6. Okay, make sense? Okay, let's look at number 27. Tell me what I'm going to reduce here first. 27. 12 and 6, that's right. So I'm going to divide by 6, right? So it's going to be 1 and 2. What else? 5 and 5, good job. So I'm going to divide 5 and 5, they cancel out. And what is left? 2 times 7. What is 2 times 7? I'm just going to write it to see some work.
14.
Yes. Okay. So that's how you do that. Now let's do 28 and 29. So reducing fractions. So 28, what you going to cancel?
The 8s.
8 and 8. Is there something else?
And the 7s.
7 and 7, that's right. And what is left?
15 over 4.
Yes, 15 over 4. Just leave it like that. Leave it as a fraction. Okay, let's do one more. Okay, here 29. So what you have? There's nothing to reduce, right? There's nothing to cancel. So what you can do, you can just multiply them. So 9 times 2 is 18. 18 times 11 is 198. So just multiplying those numbers left. Because in the bottom you have 1, 1, 1. Just leave it over 1. Okay? That's right. Now let's go ahead and do the other one. Number 30, let's finish everything. Number 30 and number 31. So how you do that? Number 30, what you gonna reduce?
The 3 and the 9.
3 and a 9. So reducing, divide by 3, so that's 1 and 3. Okay, something else? What else? 6 and 3, there's no 6.
Can we cancel the 3, the new 3 that we?
Yes, absolutely, yes, good job. We're canceling 3 and 3. So I have 1 down and 1 up. So dividing by 3 up and down, yes. And then you just multiply 5 times 10 is 50. Okay, good job. So after you cancel, okay, got it. Okay. So after you cancel what is left, if there's number left, you can reduce more, you can just continue, okay? Let's do the last one, 31. So what you're gonna divide here?
25 and 5.
25 and 5. So can you divide 5 and you have left with 5 in the top. What else?
Then you get rid of the other 5.
Get rid of the other 5. That's right. So I have 1 and 1 in the bottom, right? Okay, what else?
4 and 2.
4 and 2, I'm going to divide by 4. By 2, it's going to be 1 and 2. And what else? Is there something else?
The 2 and the 2.
2 and a 2, that's right. There's one more, 2 and a 2, and you have 1 and 1. So what is my answer? What is left?
1.
Just 1, that's right. If there's nothing left, it's 1. Okay. So that's how you do this. Reducing first and then multiply and get the reduced fraction. And here we have another thing we have to do to prepare us for scientific notation and conversions. So this, what we just did, reducing fraction, is going to help us when you convert different units. It's going to help us to reduce the answer. Okay. The next one we have is page 28. And 28, it's about find each of the following. Be sure to include the correct unit. So when you do conversions, it's very important to keep the unit with you, okay? Because the conversions are pretty much changing different units. So here we have to find the perimeter of the triangle. So they give me the sides of the triangle and how you're gonna get the perimeter. The perimeter is when you add all the sides, right? So I'm adding 24 yards plus 24 yards plus 24 yards, right? They're the same. Which means you can technically multiply 24 by 3, right? I'm gonna do that. 3 times 24 yards. So what is the perimeter? 72 yards, right? Okay, everybody understand that? So finding perimeter is just adding the sides. Okay, the next one, number 33, says find the amount of fencing needed to enclose the rectangular. We have the feet given 24, 24, 13, and 13. So if I want to find the perimeter, I need to multiply 2 times 24 because these are two sides with 24 feet. So it's going to be 2 times 24 feet plus 2 times 13 feet. Oops. These are two sides with 13. And then I can just do the math from there. Okay, so what you get, 24 times 2 is 48. So this is not.
Is it 74?
48 plus 13 times 2.
which is 26.
Yes, 26 plus 48, yes, 74. Yes, that's right. Hold on, my pen is not working right now. Just a second. Give it a minute. I don't know why it's not responding. Something going on. Okay, so when you multiply 24 times 2 is 48 plus 26 is going to be 74 fifths. So that's the answer for this one. Okay, so the next one is we have to find the area of the square. So when you find area is length times width, right? Which in this case you have the same 8 and 8. So when I multiply 8 times 8 is going to be 64. So I'm going to write the area formula is because it's a square, it's going to be the side square. In this case, it's going to be 8 meters is the side. When I square it, it's going to be 64. What is going to be the unit here? What do you think? Meter square. Okay, so keep in mind when you find area, the unit is going to be square, meter square, feet square, yard square, whatever it is square. If you find a perimeter, you add in yard, you add in meter, so it's going to be meter or whatever, yard, feet, okay? So area is always square, unit square, okay? The next one is area of rectangle. So in this case, you're going to have, I'm going to write the formula for the area is length times width. So it's going to be 24 feet multiplied by 13 feet. And what is that? It's 312. Yes, that's right. But what is the unit here? It's going to be feet square. That's right. Or square feet. So it's going to be 312 square feet. Okay? So keep in mind when you have perimeter, it's a unit, only one, keep the unit. When it's an area, it's a square of the unit. And when you have a volume, it's going to be, what do you think is going to be?
Volume equals length times width times height.
Yes, that's correct. That's the formula to find the volume. That's right. So the volume of this cube is going to be length times width times height. Now, in this case, it's a cube. So all the sides are the same. So I'm just going to put a cube because it's the same number. Okay. And in this case, I'm going to have 5 inches is the side. And I need to cube it. So it's going to be 5 times 5 is 25 multiplied by 5. It's going to be 125. What is the unit now?
Inches cubed.
Cubic inches, that's right. And I put this in purpose like this so you can see why it's inches cubed. Because if I have 5 inches cubed with power 3, what that means, this power 3 is going to apply to the 5 and it's going to apply to the inches also. So the inches also going to be cubed. Make sense? Okay. Let's go ahead and do the next one. The amount of sand needed to fill a box. If you're going to fill the box, is that volume or area or perimeter? What is it?
Volume.
Volume.
Volume. Good job. And I'm going to draw a little box here. So we have it's 24 by 13 by 3. So this is the dimension of the box We have feet, everything is feet. Okay, so finding the volume, we have to find the volume, and you're gonna multiply length times width times height. So multiplying 24 times 13 times, or let me write it proper with the units. Because I have 24 feet multiplying by 13 feet multiplying by 3 feet. So I have the answer here. What you say is it's 936. Thank you, Zane. Okay, 936, is that correct? Cubic feet. Okay, so keep that in mind when you do conversions. The units also multiply. See here you have, you're multiplying feet times feet times feet. That's 3 times, which give you the exponent 3. Okay, so that's what we have here, and we're gonna just do a little more here. Which exponent indicate the length? What is the exponent for the length? What do you think it is? The exponent what? The exponent 1, right? For area, what is the exponent? Square, right? Because all the units for the area, they're square or something. And when you have volume, what is the exponent?
Cube.
The cube. The unit has exponent 3, okay? So keep that in mind when you do your finding all of these things, okay? The exponent is going to be different. And here we have to go with this table. And we have, this is also, we're going to try to finish numbers page 30 also. We have time. Okay, and then you're going to start the next time with page 31. Okay, so let's go ahead and finish these 2 pages. So we have we have to place the check mark in the column that apply to each type of measurement. Okay, so here we have to answer this question. So if I have centimeter, so look at the centimeter. Is it, so let's talk about imperial or British unit, which are the metrics. So the metrics are the one like meter, centimeter, which have we have the prefix centi, deci, and stuff like that. And the units we're using here, like inches and what else we're using here? Miles, okay? So these are the, or what else? I'm looking at this right now. What else we can have? Like, so these are the British, the imperial, okay? So let's start with centimeter, and I'll explain that. So centimeter, what you measure with centimeter, is it length, distance, 1 dimension, 2 dimension is area, 3 dimension is volume. Okay, some of the units they measure in the mass, which is kind of the weight, time, like looking at this years measure time, right? So let's start with centimeter. So centimeter, it's length, area, or volume. Tell me this. Is it 1 dimension, 2 dimension, or 3 dimension? Just centimeter.
Length.
Yes, it's 1 dimension. That's right. I'm going to put the check mark here. Okay, that's right. Everybody understand what you're doing? 1 dimension. That's right. So that's centimeter. It's 1 dimension. Now, centimeter cube, cubic centimeter. What is going to be? Length, area, or volume?
Volume.
Volume, that's right. Inches square, what is it? Length, area, or volume?
Area.
Area, 2 dimension, that's right. The square tells you what dimension is. Now, gram, what you're measuring with gram? How
Mass.
many gram? It's a mass, right?
Mhm.
You're weighting it, how many grams? Now, the next one is hexameter. What is that? Like centimeter, hexameter. That's
Metric.
length also, that's right, good job. Deca gram is the next one, it's called Deca gram. So what is that? You're measuring what with that?
Mass.
Mass, good job. Now, years, what is years? Obviously, it's time, right?
Mhm.
Okay, I'll go over imperial metric in a minute. Okay, then this is deciliter. What is it?
Volume.
It's a volume, good job. Then you have decameter square. What is it? It's area.
Mhm.
And then you have millimeter square, cubic millimeter.
Volume.
Volume.
And then the next one is, what is it? Meter. One
Length.
dimension, right? That's right. And then miles. What is that? What you measure with miles?
Length.
Length also. Good job. Okay, so that's how you categorize all of these units, right? Now, the other part I want to explain is which one is imperial and which one is metric. So through all of this, the imperial, the one you're using in the States, so it's going to be inches square is imperial. What else? Looking at this, we have the years is also imperial. I mean, this is universal, everybody uses years, right? But it's British, it's imperial. And also the miles. So these three are imperial units and everything else is metrics. So everything else, you can just put the check mark for the rest of it. Okay, everybody understand this? Any questions? So next time we're going to change between all these units. We're going to talk about the metric, how you change the units. We're going to talk about the imperial, how to change from unit to unit, okay? Everybody get that?
Yes.
Okay. So the next page, the last page I'm going to go over is form a unit ratio for the following conversions. Identify whatever the conversion is measuring length, area, or volume. So here we have so what is the unit ratio? Unit ratio is over 1, technically, is something over 1. So the unit ratio means it's something over 1. That's the unit. So it's gonna be, I'm gonna put number over 1. That's the unit ratio. So now this is 1. So now if I wanna change, if I wanna make the unit ratio inch, 1 inch is, so here they give you the, like a conversion, we're gonna talk about conversion table like next time. So we have 1 inch is equal to 2.54 centimeters. So if I wanna make the unit ratio, I'm gonna put 2.54 centimeters over 1 inch. Okay, so that's how you do the unit ratio. Everybody understand that? So let's go ahead and do number 40. If I have 12 inches is equal to 1 foot, what is the unit ratio? It's gonna be the number 12 inches over 1 foot. Okay, that's all. Everybody get that?
Yes, ma'am.
Okay, so let's just finish this, and that's what we have for today. So let's go ahead and finish. 1 foot is 0.3048 meters. So how you gonna get the unit ratio? You're gonna have 0.3048 meters over 1 foot. Okay, the next one is 1 square mile is 640 acres. So how you gonna write that? What you gonna put first?
640.
That's right, 640. And you're just gonna keep the unit, acres, over 1 square mile. Okay? Everybody good? Okay, let's do the next one. 1 liter is 0.001 cubic meter. So how you write this one? Which number is gonna go first?
0.01 or 0.001, sorry.
That's right, good job. Let me put my computer, okay? So it's gonna be 0.001. Make sure you keep the unit over 1 liter, okay? Now the next one is 3 feet equals 1 yard. So what is the unit ratio here?
3 feet.
3 feet,
Over 1 yard.
yes. Okay. Then we have 9 square feet is 1 square yard. So it's gonna be 9 square feet is 1 square yard. Now, if you notice here from 44 to 45, if you notice, if I take the unit ratio from 44, and if I square it, I'm gonna get exactly 45, right? So if I do 3 feet is 1 yard, right? If I square everything, what you squaring on, not only the numbers, you're squaring the units also. That's what I told you before. Remember that. If you square the number, you have to square the units or the exponent. If it's cube, you're gonna cube it, right? The same idea. So it's gonna be 9 square feet, and 1 square is 1 square yard. You square everything, okay? So keep that in mind. That square apply for 3, for the feet, for the 1, and for the yard also, everything inside, okay? And then the last one we have is 1 ounce is 29.5735 cubic meters. So what you gonna put first?
The 29.5735 centimeters cubed.
That's right. And it's gonna be over 1 ounce. Okay, that's right. Okay, good job. So that's how you do this. Okay. Any questions?